is the second part of the WOW video. I ran out of battery power again. So this is part 284C3M1b6, and it's part 2. Line 22f1fa19c3m1b6, part 2. Dirac spin ice monopoles lattice beer 5G WOW Seti. Okay, so I'll just splice these together when I put them up on YouTube. So we were talking about spin ice. And I was reading the quote from Wiki. Spin ices are materials consisting of tetrahedra of ions, each of which has a non-zero spin, which must satisfy some 2-in, 2-out rule, analogous to water ice because of the interactions between neighboring ions. Spin ices are geometrically frustrated magnetic systems. While frustration is usually associated with triangular or tetrahedral arrangements of magnetic moments coupled via anti-ferromagnetic exchange interactions, spin ices are frustrated ferromagnets. Using neutron scattering, the magnetic moments were shown to align in the spin ice into interwoven tube-like bundles resembling Dirac strings. At the defect formed by the end of each tube, the magnetic field looks like that of a monopole. Using an applied magnetic field to break the symmetry of the system, the researchers were able to control the density and orientation of these strings. A contribution to the heat capacity of the system from an effective gas of these quasi-particles is also described. The effective charge of a magnetic monopole in a spin ice has been measured as 5 UBA, or magnetons per angstrom. The elementary constituents of spin ice are magnetic dipoles, so the emergence of monopoles is an example of the phenomenon of fractionalization. November 23rd, my thoughts. That new material idea with the self-charging capabilities that came up in another video. I think this magnetic dipoles and Dirac strings theories are also mentioned in many of the WOW alien radio signal data videos. I wonder if there's a formula hidden in them. I'd have to do a cross-reference to find out. So quote data in the PDF is Dirac strings and magnetic monopoles and spin ice. DY2TI207. And there's a list of the scientists there. And they're from Germany, Argentina, UK, everywhere. Okay, and so the sources of magnetic fields, magnetic monopoles, have so far proven elusive as elementary particles. Condensed matter physicists have recently proposed several scenarios of emergent quasi-particles resembling monopoles. A particularly simple proposition pertains to spin ice on the highly frustrated pyrochlore lattice. The spin ice state is argued to be well described by networks of aligned dipoles resembling solenoidal tubes, classical and observable versions of a Dirac string. Where these tubes end, the resulting defects look like magnetic monopoles. We demonstrated by diffuse neutron scattering the presence of such strings in the spin Dysprosium Titanate DY2TI207. This is achieved by applying a symmetry-breaking magnetic field with which we can manipulate the density and orientation of the strings. In turn, heat capacity is described by a gas of magnetic monopoles interacting via magnetic column interaction. That's from sciencemag.org. So I'm going to Google the keywords found in the PDF data of pichlor lattice. Quote from Wiki, pichlor is a solid solution between the niobium end member and pichlor and the tantalum end member microlite. The pyrochlore structure shows varied physical properties spanning electronic insulators, ionic conductors, metallic conductors, mixed ionic and electronic conductors, spin ice systems, spin glass systems, and superconducting materials. So there's a picture of it there. See this little guy here? Interesting shape. Child spin state and pyrochlore lattice. Quote from blog, time reversal symmetry breaking and spontaneous Hall effect without magnetic dipole order. There's the name of the scientists working on it, and they're from Tokyo, Japan. So spin liquids are magnetically frustrated systems in which spins are prevented from ordering or freezing owing to quantum or thermal fluctuations among degenerate states induced by the frustration. Chiral spin liquids are a hypothetical class of spin liquids in which the time reversal symmetry is macroscopically broken in the absence of an applied magnetic field or any magnetic dipole long-range order. That's from nature.com. Here's a graph here showing the temperature and quantum critical point, spin orbital singlet, and antiferromagnet, competition between magnetic exchange and spin orbit interaction. November 23rd. My thoughts. 2 keywords hit me right away. Niobium and tantalum. Both are mentioned in the WOW alien radio signal data videos and are in several formulas. See the above diagram? This reminds me of the core of the UFO. 2 spinning orbits on either side, and a quantum critical region is the floating circle of the core of the ship. Google keyword solenoidal tubes, and up comes the precision drift tubes at CML, which is part of the Higgs boson signal that you found. Quote data, muon tracking and triggering with gaseous detectors in some applications. It's from Geneva, Switzerland. In this review paper, the present state of art muon detection systems using gaseous detectors at the Large Hadron Collider is described. Beginning with the discussion of the concepts of muon detection systems, a comparison of the various technologies used is made with respect to the challenges that present experiments, and developments for future upgrades are discussed. Starting from wire chambers, micro-pattern detectors are described, and their readiness for upgrade is highlighted. Aging, long-term, sustained operation, and factors affecting gas choice are discussed. Finally, some applications outside particle physics are also presented, and that's from ScienceDirect.com. So the keyword to Google search is Sommerfeld. Quote from Wiki, Arnold Johannes Wilhelm Sommerfeld, FormMRS, was a German theoretical physicist who pioneered developments in atomic and quantum physics. So X-ray wave theory is a key word, and this little graph came up here. Circle genometer, Eulerian or Kappa geometry. Quote from blog, the atoms and crystals interact with X-ray waves in such a way as to produce interference. Because crystal structures contain planes of atoms, each plane will reflect incident X-rays differently. For example, let 2 monochromatic X-ray beams of a specific wavelength strike a crystal structure at an incoming angle of theta. Ray 1 will reflect off the top atomic plane, while ray 2 will reflect from the second atomic plane. However, because ray 2 has to cross deeper into the atomic plane, it travels distance 2a farther than ray 1. If the distance 2a is equal to the integral number of n times lambda of wavelengths of 2 waves, then ray 1 and ray 2 will be in a phase, thus constructively interfere when they both exit the crystal. So that's profil.mit.edu. And here's another atomic planes graph here. Quote from blog, from Bragg's law, we know that n times lambda equals 2d sin theta. Therefore, if we know the wavelength lambda of the X-rays going into the crystal, and we can measure the angle theta of the diffracted X-rays coming out of the crystal, then we can determine the spacing between the atomic planes. This spacing is called the d-spacing. If we now reorient the crystal to a different atomic plane, we can measure the d-spacing in other planes. By doing multiple X-ray diffractions at different crystal orientations, we can determine crystal structure and the size of the unit cell of the crystal. That's profil.mit.edu. And here's another graph that I found. Crystal lattice incident beam. Quote from blog, circle coincides with sphere of reflection. Second order reflection also satisfies Bragg equation, and halite goes to 4. These are points in reciprocal lattice. 100, 200, 300, higher numbers related to n, and Bragg equation in case of halite goes to 4. And that's www.go.cornell.edu. So I could Google the keyword Ewald sphere, and this is what comes up. So it shows an X-ray beam going into a crystal, and then it's reciprocal lattice, and then it's being expanded. So it's originated by Bernoulli, but more properly known as Ewald sphere. Data is from people.mbi.ucla.edu. Quote from Wiki, Bernoulli sphere. A Bernoulli sphere is a type of space habitat intended as a long-term home for permanent residents, first proposed in 1929 by John Desmond Bernal. The Ewald sphere. The Ewald sphere is a geometric construct used in electron neutron and X-ray crystallography, which demonstrates a relationship between the wave vector of the incident and diffracted X-ray beams, the diffraction angle for a given reflection, and the reciprocal lattice of the crystal. Again, all these videos do lead up to a formula, just so you know, and what I'm doing is just going through the keywords to see what they mean. Okay? So thanks for watching, and there's more videos with this series. Okay, another WOW video here. This is just researching keywords. Part 284C3m1b6. Line 22f1fa19c3m1b6. Dirac, spin, ice, monopoles, lattice, sphere, 5G Wow Seti. So there's the alien radio signal there. Electrical leads. So I'm going to Google electrical leads. Quotes from Wiki. Leads are used for physical support, to transfer power, to probe circuits, see multimeter, transmit information, and sometimes as a heat sink. Keyword is capacitance. Is the ability of a body to store an electrical charge. The energy measured in joules stored in a capacitor is equal to the work done to charge it. Keyword is conducting sheets. Eddy currents in finite conducting sheets. This paper deals with eddy currents in bounded plane conductors. Specifically, we're concerned with the semi-infinite plane sheet and a conducting disk. The eddy current distribution in a perfectly conducting sheet or disk due to a magnetic monopole source is obtained by a technique due to Sommerfeld. Sommerfeld's analysis for the disk is incomplete, but we have completed the derivation for this geometry. The eddy current decay in a semi-infinite sheet of finite conductivity is solved by an approximate technique. The results are used to calculate lift, drag, and transverse forces on a magnetic monopole moving parallel to the edge of a semi-infinite sheet of finite conductivity. That's from 1971, and that's jap.aip.org. Keywords to Google: magnetic monopole. Quote from Wiki: a magnetic monopole cannot be created from normal matter such as atoms and electrons, but would instead be a new elementary particle. Sorry. In this paper, Dirac showed that if any magnetic monopoles exist in the universe, then all electric charge in the universe must be quantized. So there's the direction it goes. That's an impression of a spin spaghetti of Dirac strings. ScienceDaily.com. Quote from the blog: magnetic monopoles detected in a real magnet for the first time. Science Daily 2009. Researchers from Helmholtz, Zentrum Berlin für Materialien und Energie have, in cooperation with colleagues from Dresden, St. Andrews, La Plata, and Oxford, for the first time observed magnetic monopoles and how they emerge in a real material. Magnetic monopoles are hypothetical particles proposed by physicists that carry a single magnetic pole, either a magnetic north pole or south pole. In the material world, this is quite exceptional because magnetic particles are usually observed as dipoles, north and south combined. So that's from ScienceDaily.com. Keywords are Dirac strings that carry a magnetic field. Quote from blog: single crystal of Dysprosium Titanate. This material crystallizes in a quite remarkable geometry, the so-called pyrochlore lattice. With the help of neutron scattering, Morris and Tennant show that the magnetic moments inside the material had reorganized into so-called spin spaghetti. That's from ScienceDaily.com. So the keyword is Dysprosium Titanate. Data keyword leads to spin ice. I'm running out of battery power, so I'm going to probably be making 2 videos for this one, okay? The arrangement of hydrogen atoms, black circles about oxygen atoms, open circles in the ice. Okay, so spin ice. Quote from Wiki: recent experiments have shown strong evidence for the existence of deconfined magnetic monopoles in these materials, with analogous properties to the hypothetical magnetic monopoles postulated to exist in the vacuum. Spin ices are materials consisting of tetrahedra of ions, each of which has a non-zero spin, which must satisfy some 2 in, 2 out rule, analogous to water ice